Welcome. In this video, we'll take a look at another definite integral. We have an integral from -2 to 1 of x, or 5x squared minus 7x plus 3 dx. So it looks like we can just start taking some antiderivatives of each of these terms. So let's start from left to right. 5x squared, we can take its antiderivative, leave the constant power x, raise it to the 2 plus 1, which is 3, and divide by our new power of 3. So we have an antiderivative of 3 over 5 x to the third. Minus, we'll have 7 x is now going to be raised to the second power, divide by 2. And then the last being plus 3. Really, we have an x raised to the 0 sitting over here, so we'll raise 1 to that power, and that will be just x to the 1 divided by 1. Doesn't do anything, so we'll just have 3x. And now we are ready to evaluate this at 1 and -2. So let's start our evaluation. We'll do it down below, but again, we're going to be wanting to find really big F, or the antiderivative at 1 minus the antiderivative at -2. Again, per the fundamental theorem of calculus, this is going to find our area under the curve from -2 to 1. So let's evaluate at 1. We'll have 5 times 1 cubed over 3 minus 7 times 1 squared over 2, and then plus 3 times 1. We'll subtract from all of this, and we'll usually want to put a little bracket around that. Subtract that from the evaluation at -2, so we'll have 5 times -2 quantity cubed over 3 minus 7 -2 quantity squared over 2, and then finally plus a 3 times the -2. Now it's time to start to simplify this result. We've got a lot of fractions to work with. We'd like to get into the simplest form possible. So we'll just take it slow. We have 5 times 1 over 3 is just going to be 5/3 minus 7 over 2 plus 3. We'll notice that we'll be subtracting everything here on the right side. So on the right side here, we should be changing the sign, distributing that negative sign all the way through. So let's take a look at the first term. We'll have 5 times -3 cubed. In the numerator there, that would be -8 times 5, which would be -40. So we'll have really a plus 40 over 3 when we distribute this negative sign. So plus 40 over 3. Then in the second term, we'll have 7 times -2 squared, which is 4. So -28 here. Again, with that distribution of the negative sign, it'll be a positive 28 over 2. And then the last term we'll have is going to be 3 and -2. Right here gives us -6, but again, we're distributing the negative sign there, so that will be a positive 6 at the very end. So let's continue our process here. We have some fractions with like terms, so we'll add these. 5 and 40 become 45 over 3, which actually happens to be really nice. And we'll work with that later. We still have negative 7 over 2. We'll have plus a 3. And we have a 6. And notice that 28 over 2, that's going to be a 14. So 14, 6, 3 are all going to give me 23. We notice that 45 over 3 here is just going to give us 15. So we can go one step further. 15 and 23 give me 38, or sorry, 38. 38 minus 7 over 2. If we go to represent this with power, or a denominator of 2, we can multiply here and give one final result. 2 and 38 give us 76 over 2. So our final result here, we can say, is going to be 69 over 2. Or we can represent this as, looks like 34.5. So this will be our definite integral result. Hope this is a helpful definite integral, and I hope to see you in the next video.